Okay, so we want to do the line integral of this vector field. So f of xy is this given vector field here, and c is the part of the parabola y equals x squared going from 1, 1 to 2, 4. Okay, so remember when we're doing line integrals of vector fields or line integrals with respect to dy and dx, then the orientation of the curve matters. So this curve looks like this. So this is the xy plane, this is x, this is y. If I sketch what the curve looks like, it's going to look like this. And we want to go from the point 1, 1 to the point 4, 4. So we're going to go from this point to roughly this point here, just this part. And notice we're going from the point 1, 1 to the point 2, 4. So we start at 1, 1 and we go this way to the point 2, 4. This is different than going from the point 2, 4 to the point 1, 1. So for example, if F is a force field and it is moving a particle along this path here, this integral is the work done to move the particle from this point to this point. And that is going to be negative of the work done to move the particle from this point to this point. So the direction of the curve is very important here. Well, it's important. The direction of the curve is important. Otherwise, your answer will be off by minus 1. Okay, so the general formula for the line integral of a vector field is the following. It is equal to the integral from t equals a to b, f evaluated at r of t dotted with r prime of t dt. Another way to write this is the integral from t equals a to b, f of x of t, y of t dotted with r prime of t dt. So to answer the question that we have, we just have to fill in this stuff over here. So step 1 is to find a parameterization. So the parameterization is going to be r of t is equal to t comma t squared. So remember, if you're on this parabola, your y coordinate is the square of your x coordinate, and that is exactly what this parameterization is saying. The y coordinate is the square of the x coordinate. And so since the x coordinate is equal to t, and x goes from 1 to 2, this means that t is going to go from 1 to 2. Pictorially, when t is equal to 1, we start at the point 1, 1, and this is a parabola. It traces out a parabola. When t is equal to 2, r of 2 is equal to 2, 4. So it starts here and ends here. Okay, and we see from this formula that we need r prime of t. So r prime of t is equal to 1, 2t. Okay, and just keep in mind that this is x of t, and this is y of t. Okay, so now let's just try to plug stuff into this formula here. So the integral over c of f dotted with dr. Now we're just going to use the formula. This is the integral from t is equal to 1 to 2. 1 to 2, that's where those bounds come from. Okay, now I will evaluate the vector field. So in the vector field, this is my equation for the vector field. So wherever I see an x, I'm going to put a t. Wherever I see a y, I'm going to put a t squared. So the first component of the vector field then becomes t sine t squared. And then the y component, or the second component, is going to be t squared. And I'm going to dot it with r prime of t, which is 1 comma 2t dt. And this is equal to the vector field t equals 1 to 2 t sine t squared plus 2t cubed dt. Okay, and so now this is the integral that we need to solve. Now at this point, this is now just a Calc 1 problem. It's a Calc 1 problem, and you can solve it using any method that you want. So this is going to be equal to, so I'll split this into two integrals. This is going to be the integral from t equals 1 to 2 t sine t squared dt plus 2 times the integral t equals 1 to 2 t cubed dt. Okay, now for this first integral, This is going to be u sub. We're going to say u is equal to t squared. So du is equal to 2t dt. So the first integral will have 1/2 times the integral sine of u du, and the bounds, well, u is equal to t squared. So if u is equal to t squared and t is equal to 1, the bottom bound is going to be top. The bottom bound is going to be 1, and the top bound, well, if u is equal to t squared and t is equal to 4, this is going to be 4. And then now it's going to be plus, let's just do this integral. Well, the antiderivative of t cubed is t to the power of 4 over 4. So 2 over 4, that's 1/2. Okay, t to the power of 4. So it's going to be 2 to the power of 4 minus 1. 2 to the power of 4 is 16. 16 minus 1 is 15. And this, okay, so now we can do this integral. So there's a 1/2 here. So this is going to be 1/2. Now this integral, the antiderivative of sine u is cosine or minus cosine u. So this integral, just the integral part, not the 1/2, but just the integral part is going to be cosine of 1 minus cosine of u. So this is cosine 1 minus cosine 4. And we add the plus 15, or add the 15. Okay, and so final answer, let me just write this a little more clearly down here. This is 1/2 15 plus cosine 1 minus cosine 4. Okay, but again, the new part is getting from this integral here to this integral here. Everything after that is just a Calc 1 integral that you can do in any valid method that you want to do.